Good evening. Today's quote is, everything you have ever wanted is on the other side of fear. Everything you have ever wanted is on the other side of fear. Today's word is souvenir, something you buy or keep to help you remember a holiday or a special event. In Marathi, Smaranika kiva Smruti Chinna. I brought back a menu as a souvenir of my trip. Now, this is the graph of fractional part function. See, what is the domain? All real numbers. And what is the range of the function? It is semi-open interval 0 to 1. Only fractional part is to be considered. This is very interesting. So, consider values of x from 0 to 1. From 0 up to 1. What is the value? 0, right? And that is why value means value of the function. So it is always on y-axis. This is the line y equal to 1. You will notice that hollow circle is drawn here. Why? Because when x is 1, what is the fractional part of 1? 0. 0 means origin. Because at origin only value of y, that is y coordinate is 0. So from 1 to 2, suppose it is 1.1. So 0.1, yes, 0.1 is the value. Suppose it is 1.999. So what is value of the function? 0.999. But when x is 2, what is the fractional part of 2? It is 0. Yes, this point lies on the graph and so on. Same is for negative values of x. Okay. This will not be asked in exam, but you should know how graph of fractional part looks like. Okay. Miscellaneous exercise 27th one. If a square plus b square equal to 7ab, show that log of a plus b by 3 is half log a plus half log b. Actually, we can begin with this to obtain desired result, or we can say we have to prove this, that is to prove, that is to prove. Then we get a square plus b square equal to 7ab. We have to say which is true, given. Now add twice ab. So a square plus 2ab plus b square, 7ab plus 2ab is 9ab. Now this is a plus b bracket square. Two numbers are equal, so their logarithms are same. Before that, rearrange the terms. A square upon b square is a upon b square. Take log of m raised to n log m. On RHS, what is log ab? Log a plus log b. Divide both sides by 2, because when we are asked to prove something, we have to prove the same thing. Suppose you say, no, from this, can we obtain the given? Yes. Backward process. We have to prove this, that is to prove, that is to prove, that is to prove, that is to prove, which is true, like that. Right.
Sum number 29. Log of log to sir, how should I read the whole thing?
Try.
If log of log x to the base 3 to the base 2 to the base 3 is 1, show that x is equals to 6561.
Okay, right down. So log of what? Log of what? Log x to the base 3, and the original base is 3, but log of what? Log of something to the base 2. Okay, it is 1. Now this is in which form? Logarithmic. Write this in index form. Therefore, log of log x to the base 3 to the base 2 is 3 raised to 1. That is 3. Again, we will say logarithm is the power to which base should be raised. So, log x to the base 3 is what? It is nothing but 2 cube. That is why you should know basics of logarithm. 2 cube is 8. Again, logarithm is the power to which base should be raised. So what is x? It is 3 raised to 8. It has to be 6561. Yes. 3 raised to 4 is 81. 81 square is 6561. Sum number 30, this is an important sum. Fx is given to be log of 1 minus x. Show that f of 1 upon 1 plus x is f of 1 minus x minus f of minus x. Now fx is given. What is f of 1 plus x? You have to use common sense. Whatever is written here, it is to be subtracted from 1. So log of 1, this is to be subtracted. So log of 1 minus 1 upon 1 plus x. LCM 1 plus x. Numerator 1 plus x minus 1, that is x. So this is 1. Now, what is f of 1 minus x? See, fx is 1 minus x. So whatever is written here, you have to subtract it from 1. Of course, log of. So log of from 1, 1 minus x is to be deducted. So minus 1 plus x. Minus f of x is log of 1 minus x. What is f of minus x? Replace x by minus x. So log of 1 minus minus x, that is 1 plus x. What is log m minus log n? It is log of m upon n. From 1 and 2, f of 1 upon x is f of 1 minus x minus f of minus x. We have to show 2 upon 5 less than log 3 to the base 10 less than half. That is to prove. Now LCM of 5 and 2 is 10. So multiply by 10. If multiply by positive number, inequality remains the same. So that is to prove 4 less than 10 log 3 to the base 10 less than 5. Now, what is 4? 4 is 4 into 1. Can I replace this 1 by log 10 to the base 10? Yes, I can. Now, what is n log n? Or before that, this is 4 log 10 to the base 10 less than 10 log 3 to the base 10 less than. Can I write 5 as 5 into 1? I can. And that 1 can be replaced by log 10 to the base 10. See, I'm not saying that is means that is to prove. We have to prove this. Now, n log m is log of m raised to n. So that is to prove log of 10 raised to 4 less than log of 3 raised to 10 less than log of 10 raised to 5. That is to prove 10 raised to 4 less than 3 raised to 10 less than 10 raised to 5. Now can you tell me what is 10 raised to 4? It is 10,000. What is 10 raised to 5? It is 1 lakh. And 3 raised to 10 is basically 3 raised to 5 square. 3 raised to 5 is what? 243. Now you have to find square of 243. It is 59049. Please check this. Is it true? Obviously, 10,000 is definitely less than 59,000 something is definitely less than 1 lakh. So which is true. Now listen, if you are asked to prove something of this type in which here denominator is 7 and here it is 13. So LCM of 13 and 7 is what? 91. So are we supposed to multiply by 91? That is absurd. Absurd in the sense you will have to find 3 raised to 91, something like that. So we will not do that. In that case, what we will do is, first we will prove this. Then we will prove this. In this case also you can do that. You can say, let us prove 2 upon 5 less than this. That is to prove 2 less than 5 log. After proving that, you can say we have to prove log 3 less than half. That is to prove 2 log 3. Then combine these two to get the answer. Is that clear? Right on. Now 30-second. Just listen to me, but please do write the solution after the lecture. Show that 7 log 15 by 16 plus 6 log 8 by 3 plus 5 log 2 by 5 plus log 32 by 25 is log 3. Begin with LHS. Now n log m is log of m raised to n and so on. Basically, sum of the logarithm is logarithm of product. Now we express each number as product of its prime factors. 15 is 3 into 5, 16 is 2 raised to 4, Basically 8 is 2 cube, 25 is 5 square, and so on. Okay, use laws of indices, a raised to m raised to n, a raised to mn, and so on. So you will notice that you get log of 2 raised to 28 into 3 raised to 7 into 5 raised to 7 upon 2 raised to 28, 3 raised to 6, 5 raised to 7. That is 3 raised to 1. So log 3, which is nothing but right hand side. Okay. Third, let me explain. If you want, I'll definitely give you time to write the solution. Root of log of x raised to 4 to the base 2 plus 4 log of root 2 by x to the base 4 equal to 2. Now, within radical sign, what is log of x raised to 4? 4 log x. Now, here base of logarithm is 2. Here it is 4. So I change the base to 2 using change of base rule. So it is log of root of 2 by x to the base 2 upon log 4 to the base 2. Now, what is root raised to half? Log of 2 upon x raised to half is half log. That is why 4 into half. Now in the denominator, logarithm is the power to which base should be raised. 2 raised to 2 is 4. So 2. Or you may say 4 is 2 square. So 2 log 2 to the base 2. Log 2 to the base 2 is 1. Same thing. Okay. Equal to 2. Now next step. This is this as it is. 4 into half 2. 2 gets cancelled with these 2. Now what is log of m upon n? Log m minus log n. But log 2 to the base 2 is 1. Logarithm is the power to which base should be raised. 2 raised to which number is 2? 2 raised to 1 is 2. Bring this 1 to RHS. In fact, these two terms to RHS. So 2 root of log x to the base 2 is this. Some students, they square this and so on. But if you observe, you will notice that log x to the base 2 is square of what? Its root. See, what is x? Root x square. What is y? Root y square. So this log x is what? Square of root log x. Simple. Okay. Bring this term to other side. So minus 2 times this plus 1 as it is equal to 0. Note that this is square of root log x minus 1. You can check this. A minus b square, a square, present, minus 2 times the product, plus square of the second. Now square is 0, so this must be 0. So this is 1. You need not square this because you can say log of any number to the same base is 1. Or if you want to square, you can do that also. So if you square log x to the base 2 is 1. So what is x? 2 raised to 1. That is 2. I repeat, if you are not able to understand this, please square and simplify. In fact, you may say for convenience, take log x to the base 2 as y. So 2 root y is 1 plus y, square and so on. Finally, you will get the same thing. Sum number 34. Find the value of 3 plus log 343 to the base 10 upon 2 plus half log of 49 by 4 to the base 10 plus half log of 1 by 25 to the base 10. Okay. Now, 343 is 7 cube. See, we have to express this as product of primes. Denominator 49 is 7 square. Okay. 1 by 25. Or before that, what is n log m? Log of m raised to n. Raised to half means square root. Square root of 49 by 4 is 7 by 2. And that of 1 by 25 is 1 by 5. Okay. Now, numerator as it is. What about denominator? Log m plus log n, log mn. So 3 plus 3 log 7 to the base 10 upon 2 plus log 7 upon 10 to the base 10. Now what is log of m upon n in the denominator? Log m minus log n. So 3 plus 3 log 7. Now I will not say to the base 10 because base is 10 only. Upon 2 plus log 7 minus 1. Why minus 1? because log of any number to the same base is 1. Now, take 3 common from numerator. You get 1 plus log 7. What about denominator? Same, 1 plus log 7 gets cancelled. And what remains is 3. So 3 is the answer.
35th, if log a upon x plus y minus 2z is equal to log b upon y plus z minus 2x is equal to log c upon z plus x minus 2y, show that a, b, c is equal to 1.
Good. So we begin with, let each ratio be k, bracket I will say C. Okay. So what is log a? It is k into, write down, x plus y minus 2z. What is log b? K into y plus z minus 2x. And log c equal to k into z plus x minus 2y. Right now. Now what is to be proved? ABC equal to 1. That is to prove log ABC equal to log 1. But what is log 1? 0. Yes, so we take each ratio as k. So these are the values of log a, log b, log c. Now add them. I have omitted one step. It is better if you write that step also. I have directly taken k common. Please don't do this in exam. Write this plus this plus this and then take k common to get in bracket 0. So k into 0, that is 0. Now what is log a plus log b plus log c? Log ABC. I hope you won't say taking log common. This is not log into a. Now sum of logarithm is logarithm of product. So log ABC equal to 0, but log 1 is 0. So ABC must be 1. That's it. Thirty-six, show that log of x cube to the base y into log of y raised to 4 to the base z into log of z raised to 5 to the base x equal to 60. Now first I use log of m raised to n as n log m. So 3 into 4 into 5. Now I change the base to 10. If you don't want 10, you can say 7.1 also. Right? Any valid base. Now what is change of base rule? Log x to the base y is log x to the base 10 upon log y to the base 10. Same here also. So log x once in the numerator and in the denominator. Same for remaining terms. So this is 60 into 1, which is nothing but 60. Right up. 37th, if log a to the base 2 by 4 is log b to the base 2 by 6 is log c to the base 2 by 3k and a cube b square c is 1, find the value of k. Now k is already used. So I say let this be m. So find the values of log a to the base 2, it is 4m, log b to the base 2 is 6m, log c to the base 2 is 3km. Okay. Now a cube b square c is 1. So take logarithm to the base 2 on both the sides. Anyway, log 1 to any valid base is always 0. Now 3 log a plus 2 log b plus log c equal to 0. Substitute the values of log a, log b, log c. We can divide by m not equal to 0. So 24 plus 3k equal to 0. So what is k? Minus 8. Sum number 38. If a square equal to b cube equal to c raised to 4, it should be equal to d raised to 5. Show that log BCD to the base a is 47 by 30. Now you have to use common sense. Log BCD is just 47 by 30. This means BCD should be expressed in terms of a, so that we get log a to the base a, which is 1, right? Now a square is b cube, that is b cube is a square. Take cube root on both the sides. So b is a square, cube root means raised to 1 by 3. A raised to m raised to n, a raised to mn, so a raised to 2 by 3. C raised to 4 is a square. Take fourth root, a square raised to 1 by 4 is a raised to half. d raised to 5a square. So d is fifth root of a square, that is a raised to 2 by 5. It would have been better if I would have obtained the product b into c into d separately. This is also correct. Substitute values of b, c, d. Now laws of indices, LCM is 30. So finally it is log of a raised to 47 by 30 to the base a. Log of m raised to n is n log m. So 47 by 30 log a to the base a. But log of any number to the same base is 1. So 47 by 30. I'm sorry, not 29th, 39th. We're doing only one part, that is a part, and then we will depart. So you should know the concept of modulus. Let me read sum number 39. Solve the following for x. A part, 1 less than mod of x minus 1 less than 4. Now, what about modulus? If x is greater than or equal to 1, this is already non-negative. So it is mod of x minus 1, x minus 1. But if x is less than 1, this is negative. But modulus of negative number is positive. So again multiplied by minus 1. So if x is less than 1, then what is mod of x minus 1? Minus in bracket x minus 1. That is 1 minus x. Okay. Let me explain. I'll give time to write the solution. Therefore, I can say, let me explain first. 1 less than x minus 1 less than 4, or you should not say and, or 1 less than 1 minus x less than 4. Now we are interested in finding value of x, that is add 1. So 2 less than x less than 5, or now this is interesting, subtract 1. So 0 less than minus x less than 3. That is this part as it is, 2 less than x less than 5, or you have to be careful. Now we need x, but if multiplied by a negative number, inequality reverses. So in the second case, multiply by minus 1. So 0 greater than x greater than minus 3. Okay, but we write lower limit first. So I will say that is 2 less than x less than 5, or first I write minus 3. Now see, this is head and this is tail. Tail is towards minus 3. I have written minus 3 first. So minus 3 less than x less than 0. Okay. Now I can say that is x belongs to open interval 2, 5, or x belongs to open interval minus 3, 0. Okay. So what is the solution set? Their union. You can verify. See, whenever you find answer in 99% of the cases, you can verify whether what you have obtained is correct or not. For example, take any number between minus 3 and 0, say minus 2. Check with this. Minus 2 minus 1 minus 3. What is mod of minus 3? 3. 1 less than 3 less than 4? Yes. Okay. Write down. I'll again explain. First write down this. So you can write this as solution is minus 3, 0, open interval minus 3, 0, union, open interval 25. So that's it for today.